Let's continue by looking at some cycloalkanes. We've added the word cyclo in front. Cyclo just means a ring. So this is a ring of a hydrocarbon chain. So a chain becomes a ring. How does that happen? Well, let's do the simplest one here with propane. So straight chain propane. Under certain conditions, you can actually remove those hydrogens on the end. They're going to find each other and they're going to make H2. Well, then this thing's not exactly happy. Those carbons aren't stable. So what they want to do is they actually want to wrap around on itself like that. And they want to form a ring. And there is your simplest hydrocarbon. So let's make a table. So your simplest cycloalkane is, we can't have one or two, you need to at least have three. So this is the one we just looked at. Now, what I like about this is the condensed drawing, which is a triangle, because that's the shape here, right? That shape there looks like a triangle. By just drawing the triangle, it actually is considered that all of these other hydrogens are there. So as long as you know that there are two hydrogens on the ends, you're good to go. We're going to call this one cyclopropane because it's a propane, but it's a ring of three. It's a cyclopropane. So when you have 4 carbons going on, it looks a little something like that. You ask yourself, what shape is that? Well, it's a square. And this would be cyclobutane. You can just copy that down. Just draw the square. That's how I would do it. 5 carbons, looks like that, but the shape is a pentagon. It's cyclopentane. And 6, I'm going to stop at 6. We're going to go this high. This is our cyclohexane. There's a lot of chemistry involved with cyclohexane. And when you get 7, 8, or 9, or 10 in a ring, it just gets hard to draw. So I'm going to mostly focus on these versions. So let's do some naming. There's just some slight adjustments we'll make to our naming rules. We probably don't need to come up with a set of rules. So here's our first example. So the first thing you want to do is you don't necessarily worry about the longest chain. You just need to worry about the shape that you've got going on there. And that is a cyclohexane. We do want to number a ring so we get the lowest number possible. And you're always going to have something in the 1 position. The earlier lesson with our straight chains, you'll notice that we never had the number 1 on any example. If you did, something was wrong. But now with these rings, you always have something in the 1. And this one's being symmetrical, so we can actually have probably a couple of different answers. I could call that my first, that my second, and that my third. Or even vice, I could also say this is 1, 2, and 3. Either way, I'm going to get the same answer. So I got a methyl group on the 1 and a methyl group on the 3. So 1, 3 dash dimethyl cyclohexane. All right, what if we do this one here? Another example. So again, we have a cyclohexane. Now we want to number our chain, and again, this one's fairly symmetrical, so we're going to get two answers, both of which could be correct. Let's say that's the first carbon, that's the second carbon, that's the third carbon. That'll work properly. Those will give us our lowest number possible. That's what we're always after. It looks like we've got a methyl group on the 1, a methyl on the 2. The letters are reversed, but still a methyl group. And then this thing here is an ethyl group. So once again, we'll say ethyl goes ahead of methyl. So we have a 3-ethyl and a dash, and then a 1,2 dimethyl. There's your 1,2 dimethyl. Now, frankly, if we had numbered this the other way, if I had said that this is the 1, this is the 2, this is the 3, I'd actually get the same numbers. So I would probably accept either or in terms of names, because they both have the same essential numbers there. I missed a dash. This should be a dash right there. Sorry for me to draw it in. There we go. Dash 2, 3 dimethyl cyclohexane. So those are the same. Final example is just this simple one here. Your ring is once again a cyclohexane, and this group is a methyl group, methyl cyclohexane. Now some people are probably thinking, do I put a 1? Is this a 1? Well, the fact is we could turn this molecule any different direction, and that single group is always in the 1 spot. So it's just methyl cyclohexane no matter how you look at it. Complete sheets 2 and 3 and check your answers.